So welcome to our class today. Today we are looking at a question and an interesting topic under chemistry, and it happens to be Gay-Lussac law of combining volumes. So what does it say? Gay-Lussac is a French chemist who states that when gases react, they do so in volume and bears in simple ratio to one another, provided the end product is gaseous. This is what Gay-Lussac says. So if you look at the law, there are two variables they mention here. The volume of the gas that is reacting and the mole ratio of the gas that is reacting. So we are taking from the law two variables. Volume of the gas and the mole ratio of the gas. Volume of the gas and the simple ratio. That's what we are taking from the law. So how are they related mathematically? So we can have that volume is proportional to the mole ratio of the gas. So if I want to remove my sign of proportionality, my volume becomes what? This one now implies V equals to Kn. Let's make the K the subject formula. My K becomes V over N. So how do we apply this simple mathematical expression to solve questions under Gay-Lussac law? So gases that react are always two or more. So let's consider two gases, in this case, carbon 2 oxide and oxygen. Carbon 2 is always a gas plus oxygen, which is also a gas. We oxidize to give us carbon 4 oxide, which is also a gas. So if I want to balance this equation, I will add 2 here, and here becomes 2. Now we have a balanced chemical equation. So the gases that react here are carbon 2 oxide and oxygen. So how do we apply this concept now back to this original constant from the equation? So we are going to have, the first gas that reacted here is carbon 2. So I'm going to have volume of carbon 2 over volume of oxygen is equals to the mole ratio of carbon 2 in the equation over the mole ratio of oxygen in the equation. So I can arrange this expression by grouping volume to volume and mole ratio to mole ratio. As you can see, volume to volume, mole ratio to mole ratio. So let's see how we can apply this mathematical expression to tackle a question. So this is what we have. It's a hydrogen reacts with oxygen according to the following equation. So this is the equation. From the equation we see we have two moles of hydrogen and 1 mole of oxygen, even though the one is not reading, or we also know that place is 1 and 2 moles of water. So they are now telling us 50 cm cube of hydrogen now, we have a mole ratio of 2, and 30 cm cube of oxygen, we have a mole ratio of 1 according to the equation. We are asked to calculate the volume of our used oxygen after cooling to the initial temperature and pressure. So let's first of all state the mathematical expression for hydrogen and oxygen according to the equation. Hydrogen is the first gas here. I'm going to have volume of hydrogen over volume of oxygen is equals to the mole ratio of hydrogen over the mole ratio of oxygen. So let's assume we have two containers here. The first one is hydrogen, and the volume present here is 50 cm cube. The second container is oxygen, and the volume present here is 30 cm cube. So ideally, it's not all the volume of the hydrogen that will react completely with the volume of hydrogen we have here. So certain amount will react, certain amount will be left. So the question is how many volume of oxygen actually took part in the reaction. So for us to know the volume of oxygen that took part in the reaction, we are going to calculate the actual volume that actually reacted and know the volume that did not react. So let's see how that will be done. So I'm going to have I'm going to have now volume of hydrogen that reacted over volume of oxygen that also reacted is equals to the mole ratio of hydrogen over the mole ratio of oxygen. So the volume of hydrogen that took part in the reaction is 50 over the volume of oxygen that reacted. Then the mole ratio of hydrogen is 2, mole ratio of oxygen is 1. So if we cross multiply, we're going to have 2VO, which 2 times the volume of oxygen is equals to 50 times of 1. I'm going to have 50. So let's find the volume of oxygen that reacted. It's simply 50 divided by 2. Our answer will give us 25 centimeter cube. This is the volume of oxygen that actually reacted according to the equation. According to the equation. So, as you know, if you love what you are watching, for us to complete the solution, please always subscribe to our YouTube channel. So let's determine the volume of oxygen that is unused according to the question. So initially, we have 30 cm cube of oxygen. But from the what we've calculated, we've discovered that it's only 25 cm cube of it that reacted. The question is, how many is remaining, which is the volume of the unused. So let's get the volume of the unused oxygen. So volume of unused oxygen will give us VO2 unused. We give us the total volume given minus volume that reacted. Volume reacted. So what is the total volume given from the data is 30. What is the volume that reacted is 25. So the volume of our used oxygen is simply 5 centimeter cube. So this formula, if you notice, it might be unique to or new to some of you, the formula of Gay-Lussac. So you can also use this to calculate any gases that's involved, irrespective of the question. So always adopt this formula to make calculation easy for you. So if you like what you are watching, like I said, always come to our YouTube channel, STEM Up Africa, subscribe, like, and share our video. See you in our next video. Thank you.